I'm wondering if you could describe what Quorum is for people who aren't familiar with it.
Yeah, so Quorum is a programming language. So I mentioned this issue of like evidence with language design. So my lab and I thought, well, if you were to try to make a programming product based on evidence, what would that even mean and what would that be? So Quorum has become a programming language where we meticulously and rigorously and sometimes even obsessively go through every symbol, every character, every combination of semantics and whatever with human studies to try to make it easier to understand. And there's two pieces of it. One of which is the language itself, just like the raw text and all the libraries and all that kind of stuff. And we evaluate that in different kinds of ways to make it easier. But another is, very recently, we've been working toward visualization of the technology. Now, this is really hard to make accessible, so it's taken us a couple of years to do it. For example, are you familiar with Unity 3D? You ever heard of this?
Mm-hmm.
So for anybody listening that hasn't, Unity 3 is like a programming environment that involves 2D and 3D graphics. Well, how do you make that accessible? Well, we've solved that problem. And we have a version that's totally blind accessible and to other disabilities that allows you to do 2D and 3D gaming and all sorts of cool stuff inside of Quorum. That will come out in July. But in any case, if you want things like blocks or visualizations on top of programming languages to be accessible, you need to do that. And so when we eventually go in and add that kind of support to Quorum, we have to do the accessibility side first, which so it takes a little while. But for the language, really what it is, it's a programming language where a group of scholars, not just me, but people outside of my research group, have been obsessively running studies on anything you can think of to try to make the language easier to understand. If you have loops in a normal language, that would be this for left paren int I equals 0 semicolon type stuff. In Quorum, it would be repeat 10 times. And why is it those specific words? It's because we have survey data on the word choices. We have randomized controlled trials comparing it to other programming languages. And we often compare those across groups. Probably the most famous one is our placebo study. I don't know if you know that one.
No.
So in 2013, we had this idea for a study. We were trying to think of like, how would you compare programming languages and what would be the sign? Like, for example, in the medical sciences, they often use placebos, which are things like sugar pills. And then we compare against placebo to kind of give like a comparison across a set of medicines. Like if a placebo works in a certain percentage of the time, or works is a rough word, but you get my idea, then you're comparing across. But for a programming language, what's a placebo?
Right.
So what we did was we took Quorum, we ripped out all the symbols, and then I had my student mostly laughing, rolling electronic dice and randomly choosing the symbols that go in the programming language. So like they're awful. They're absolutely horrifically bad. It's not repeat. It's like left slash. So you got like left slash pound, colon, left brace for no reason, and then like a @ symbol. And students just have to figure out that that means repeat 10 times, right? So very hard to use. And you might think, cool, we got a baseline, but that seems like ridiculously unfair until we ran the study. And it turns out Perl and Java don't beat it.
Really?
And when I say don't beat in statistics usually means two things. One is it means it doesn't find a statistically significant difference between that and the group, but also crucially, it means that even if there is a difference and you could find it at larger sample sizes, it means that it's inevitably pretty small. The question then is, why on earth would that be true? And the hypothesis that we generally have is that the word choices suck.
Yeah.
The word for doesn't mean anything to a novice. And a lot of these little braces, they have weird effects that like we wouldn't have expected. Like for example, if you have the left brace inside of a programming language, like usually it's match braces, turns out novices get the left brace wrong more often than the right one. Why? I don't know, but they do. And so oftentimes in programming languages, when we design Quorum, we use that statistical data and then we make directed decisions about which things we leave in and out. So for example, an if statement in Quorum doesn't have matching parentheses because it's one of the most common errors. And this has been shown in a ton of studies since, but our data showed it as well in 2013. Neil Brown's data in the UK shows it. Brett Becker's data shows it. Paul Denny's data shows it. I mean, it's just the general consensus from a variety of programming languages shows that that's true, so we leave it out. If the left brace is more likely to be screwed up in something like a function than the right, the left brace goes away. And it turns out that works pretty well. Or like if you have an equal sign, like in programming languages, often it's double equal to imply equality.
Equivalent, yeah.
Yeah, and it turns out that if you have a single equal, it increases a novice's ability to use that in the context of an if statement by 800%.
Wow.
Yeah, I know. That's what I said when we saw the data too. And in fact, in the studies, we then go in and use assignment and equality tests right next to each other to see if we can screw up a novice, and it doesn't happen. Like novices can figure it out based on context. The point is, like, you can use all that very strategically to define programming languages where you've really thought it through. You've gathered the data, you've thought it through, you've done experiments, you've replicated those experiments, you have survey data on the words and symbols, and then you've put that all in so that people can kind of use it a little bit more effectively. And then every release we do on Quorum, we work with outside scholars that are doing different studies, sometimes to disprove us and sometimes they're right. In addition, we keep doing internal studies as well to make slow incremental changes so that hopefully in like 10, 20, 50, 100 years, programming languages are much more condensed in terms of how much garbage is in them. Because right now, there's a lot of garbage.
Right. I'm curious, in the placebo study, so I proposed to my wife by modifying the game Minecraft, which used Java. So I've used that, but I haven't used Perl. I'm wondering if you found significant differences between lower level versus higher level languages compared to the placebo.
Right. So we didn't test that in that study, but the reason that both perform badly is actually because they have a lot of syntax in common.
Okay.
The reason where they tend to screw up is actually the same across where they're the same. And in fact, in languages that did slightly better than placebo, like Python did slightly better, it actually, where Python does badly is the same places where it matches the syntax for Python and Perl. And the reason is they use the same words and symbols, right? It just has a colon at the end instead of a brace and a match and stuff like that. So the reason why Python does slightly better is actually accidental. They still have a lot of the cruft from, the 60s and 70s that didn't get rid of, but they have a couple decisions that made a small difference. And in fact, in those original studies, Quorum did better than Chance, but it did pretty badly too in a lot of ways. And we made a ton of changes since 2013 that are based on that evidence from that study and many others.
That's great. Yeah, in my coding classes, the kids had the opportunity to pick from several different languages. And one of the things that I noticed is it was easier for kids to go from a syntax-heavy language to a syntax-light language, like JavaScript to Ruby. But going the other way around, it was much more difficult because they were used to this like clear, easy to understand, quick to write, didn't have to worry about semicolons. And then when you go to JavaScript, it was like, wait, I have to add in all this other crud that I'm not used to. So they were not able to do as well with that.
Yeah, I don't have evidence on transfer of learning in both directions, but that might be true that there is different effects going either way. That wouldn't surprise me. And it's interesting you mentioned Ruby too, because a lot of what we found in those original studies as to how to make Quorum better, we actually stole from Ruby because they had some parts of the language where they did really well, like leaving off the parentheses and stuff like that. And that did really well in those studies. On the other hand, interestingly, because the whole field was non-evidence-based for such a long time, most languages make certain mistakes that they probably don't know they're making. Ruby's a good example. Ruby has dynamic typing, so does JavaScript. And it turns out dynamic typing, which is this idea that I don't tell you what the type is, I don't force you to write it. Well, it turns out that in languages like Ruby, because they have dynamic typing, that actually significantly lowers your productivity for people, I think it's past year 3 of experience level in college. At the beginning, students do have a negative impact, and it's like really small, but it goes away quickly, and we even know why it happens. The reason is because if you videotape programmers, basically what you observe is that when it's dynamically typed, if you want to call a function, you got to know what to call it with.
Right.
But the problem is you don't know what to pass. So what you observe is developers jump to the function, try to figure out what to pass to it, and then they jump back, and guess what? That takes time, and therefore productivity lost.
And to hopefully clarify for people who aren't familiar with it. So like one example is Khan Academy's JavaScript. They use var as a substitute for any kind of type of data. But instead of using something like var, you might say int for integer or dub for double or say a string or whatever to clarify in advance. I'm going to pass text or I'm going to pass an integer that has decimal points or doesn't have decimal points, etc.
Yeah, that's exactly right. And it turns out that var type approach actually lowers people's productivity a substantial amount.
That is absolutely fascinating.
I think actually now that effect of dynamic versus static, I think it's actually the most well-studied and replicated in probably all of computer science. Off the top of my head, I want to say somewhere between 10 and 20 randomized controlled trials on that topic now, and they pretty consistently show the same effect under different contexts, with and without code completion, in and out of an IDE, under this condition, that condition. It's kind of funny, like it used to be, we used to debate that in computer science a lot, but I feel like that's a solved problem now. I mean, there's more to learn, and there's probably contexts under which, so I have to put my scientist hat on for a minute and say there are caveats, and there are. But at the same time, like, if you want to say the other direction now, you got to provide the data and show us the evidence so we can see what conditions you're testing.
This excerpt was from episode 27 of the CSK8 podcast, and it was titled Accessible CS Education Through Evidence-Based Programming Languages with Andreas Stefik. You can listen to this full interview as well as hundreds more by searching for the CSK8 podcast on your favorite podcast app or by simply going to jaredoleary.com.